Welcome to another webinar session that is conducted by 99x Technology. So today we have a brand new title to discuss. So let's get right into that. Let me just switch back to our slide deck. Okay. Right. Our title today is, guys, harnessing microservices to lower TCO for enterprise applications. Now I know this title itself is quite a mouthful, and it has these big words like TCO, microservices. So someone who's not quite familiar with this, I think first we're gonna break down these words and see what actually these words mean. So this is our agenda for today. So what we will gonna be discussing today is about harnessing microservices to lower TCO for enterprise applications. Now I know there are lots of big words here. Microservices is one of that, and TCO, aka total cost of ownership. So let's try to break down these words first and then go into our presentation. First talk about what a TCO is, and then we'll try to understand how a monolithic architecture kind of increase the TCO. And when we move from monolithic architecture to a microservice architecture, how does it really reduce this TCO or total cost of ownership? And then we'll see different architectural decisions that we can take when we migrate to a cloud environment. So the intention of this webinar is to explain how this total cost of ownership kind of varies with different architectural decisions that we take in our projects. We will take our project as the example, that means our what if project as the example, and then you guys can map those concepts and ideas to your own projects as well. Alright, so without further ado, let's start with this. So my name is Manoj Fernando. Sorry I couldn't give a brief explanation about myself earlier. I'm an associate technology lead in 99x Technology. Today joining with me we have Rumesh and Chamal. So why don't you give a little bit of introduction about yourself, guys?
Hi guys, I'm Rumesh. I'm currently working as a senior software engineer at 99x Technology. And again, to mention, I am also working with Manoj in the same project as well.
Alright, this is Chamal.
Hi guys, I'm Chamal Pradeep, working as a senior software engineer in the same project. What if? For you, let's move to the presentation.
Alright, I'm going to share the screens again. Short. Right. Alright, Chamal. So I think it's time to put our economics hats on and try to understand this word TCO, right? What does this TCO mean, Chamal?
Actually, Manoj, when we come to the software industry, there are so many fancy words like TCO, ROI. There are so many fancy words, but the behind the scene, the concept is not actually large. When we come to the TCO, total cost of ownership, that quantifies the cost of the purchasing across the product's entire life cycle. That means, as you can see, if you go to the next part, who is this guy? This TCO is the initial purchase price plus cost of operations. If you go, this is not actually a thing for software world. You can use this for real world applications also. We will explain this in details in next slides. Okay, this is the one of famous example for introducing TCO for several places. Like you can get 3 light bulbs. One is with a filament, other one is CFL, another one is LED light bulb. Then let's calculate that TCO value on the go. If you consider about purchasing price, as you can remember that early equation, our TCO is the initial price plus cost of operations. Then when we came to the light bulb, purchasing price of this filament light bulb is low. Actually it's low. But when we come to the CFL bulb, it's bit higher than that. But when we come to the LED light, it also a bit higher than that. But when we come to the operational cost, in light world there are so many operational costs. If lights goes down, then there may be several repairments we have to do. So then operational cost wise, this first version of light, this filament bulb, is higher than other lights, and in CFL bulb it's more reliable but higher than that filament bulb. But when it comes to the LED light, it is the most TCO lowest light for us. When we come to the power consumptions, this first one is taking the largest amount of power consumption. When we come to the lifespan, this is the lowest one. So when we take these things to our equation, we will get that we can remove these two lights because their TCO are lower than our LED one. So this is the basic example for calculating TCO, product total cost of ownership of a light. So we are not coming here to talk about lights. So we come to here talk about software world.
So basically, I have a question with the previous slides that you have mentioned, Chama. So basically, this is regarding total indirect and direct cost, including their value that they kind of provides for us, right? So this is kind of not just the operational costs, but it includes the value chain as well. You know, how much value proposition that we get out of this, right? It's kind of the total of all these entities.
Yes, of course. These values are not calculated for just a 1 year. It is calculating for the entire period of years that you are going to use this. Correct. So then finally the overcome will be the total of that cost.
Okay, got it.
Okay, when we come to the software industry, so as we know, we only know that there are so many words, training, purchases, maintenance, kind of things in software world. In software world, TCO calculation, purchasing price is only a single element. There are so many direct and indirect, as you said, there are so many direct and indirect variabilities will occur useful for the TCO calculation, like licensing, security, support, services. So in traditional on-premise applications, there are so many costs. They are not actually so cost effective because of these so many variables based on that TCO calculation. Because of that, we were able to discover a latest technology for reduce this TCO, because TCO reducing means we will increase the ROI. What is this ROI? Actually, simplicity, it is the benefit for using this software.
Yeah, return on investment. That's a good point that we can kind of carry on this discussion. So basically, when it comes to an enterprise, right, whatever the enterprise, private enterprise, right, the main goal for a particular enterprise or a business is, I mean, they have to focus on their core business basically, right, and they have to make some profit out of that. So when it comes to software world, I mean, there's this trend of people moving into cloud and provisioning stuff, the infrastructure as service terms coming up and platform as service coming up. But when you actually consider these things, those things are not actually matter to a particular business. What really matters is the core business. They have to have 100% focus on their core business. And now another factor, right? Rather than other than focusing on their core business and making more profits, they have to reduce their overall cost. I think these are quite, understandable when we have these type of points. So when you talk about TCO, I think we can remember when we start our What If project, it was not the architecture that we had right now. It was quite different, and we have a different name that we use to kind of identify this type of architectures. We call them monolith architectures. So since this is kind of a buzzword nowadays, I would like to get the idea, get some understanding about this word monolith from Rumesh. Rumesh?
Thank you, Manoj. So, monolithic versus microservices. So, back in the days when we developed software, what people used to do was develop everything bundled up together. So, be your web application, there may be services, web services, and everything. All those things will be bundled together. So, all of you might be aware of the entire architectures. So you have a database layers, application layers, but there are no separation of it. So in a way that simplifies the operational aspect. But if you want to change some part of your application, that will introduce a lot of difficulties because changing one component might affect the entire application. So that's where monolithic try to fall down, and where people introduce microservices was to come out of those problems, where people introduce a separate database component for separate services, and all the services layers are different and have them separately. But for a user, he won't see such a difference. He will see only a single application, but under the hood, everything will be differentiated. So say you have different services to get accounting details, that will be a separate component. Imagine you have a login system, that will be another separate login service. So all these will be different services. The advantage is if you want to modify some component, you will be modifying it only in a certain area which wouldn't affect the entire application. So that's the difference between the monolithic and the microservices.
So Ramesh, since we are much focusing about these costs, right? I mean, even our title is, it's regarding this TCO, how to reduce it by migrating to a microservice architecture from monolith architecture. So what are the ways, I mean, can we actually calculate the, TCO of a monolith and show our viewers, how much, it would cost?
Yes, actually we could. Before going to that, I would like to briefly tell you about what we had in the beginning and where we sort of identified what are the fallbacks are, and then let's move on to the cost calculation.
That's a good idea, yes.
So Manoj, initially what if project, so entire domain is revolved around risk industry. So what we do is basically provide a solution to make risk analysis, vulnerability assessment, and the readiness of these risk industry. So our project is mainly based on Norway. So a lot of big players in the Norway are currently using what if solutions. And talking about the industries, shipping industries, all the manufacturing industries, as a government regulation, they have to provide all these risk analysis report to government. So risk industry is a huge industry in Norway, and what we do is we provide all the tools which can be used to make all the management decision to the risk decisions. So if we move into the next slide, Manoj, what we had initially. Basically, it was a very simple application which had the Ruby on Rails backend and front end was entirely written on Backbone and jQuery. So they might have a separation where the front end is separated and the back end is separate, but all of them were in the early days. All of them were coupled together. So we later on we introduced a mobile application which was hybrid mobile application. To cater that, we introduced a REST API on the Ruby on Rails application. But then again, all the service components were bundled up together. So there were no separation in all these services. So if we look at how we deployed our service, what we had was just a single dedicated server which was hosted in Norway. So in the same server, we hosted a Ruby on Rails virtual machine and the database server, so which was a MySQL server. So talking about this, the main difference is back in the days, cloud was not that popular. So what we had to do was purchase every servers from Norway. So which was bit of cost. because all the management aspects, the backups, and all the operational part they had to manage, and it was a really high cost for the business. So that's where I think we can do a bit of a cost analysis there.
Yeah, I think it's ideal to do some cost comparison between this monolith and how the cost varies when you kind of move into a microservice architecture. Chamal, I think you have something to share with us.
Yes, Manoj, can we go through the application? Okay, let's, as Ramesh says that we move to the AWS solutions, cloud solutions, because of these drawbacks in monolith architecture. So when we come to the TCO calculation, if we are buy some product tomorrow, we first do TCO calculation in our home. That's the nature. In software industry also, this also nature. If we come to the monolith architecture, we have several basic and fundamental costs we have to calculate. First one is server cost. Second one is storage cost. Definitely we have to allocate those things to up and running the application. After that, network cost, IT labor cost. We can see directly these cost as a calculation. But the problem is, Manoj, we have several overhead costs we cannot measure directly. We call it as an indirect cost. Like in a server cost, space, power, cooling kind of things. There are so many things that we not mentioned in these slides also. In storage also, space, power, cooling.
Yeah.
There are several overhead costs. So actually that's why we title this as a comparing TCO is not that easy.
Can't we do it at all?
We can. There are so many solutions available in outside world that we can calculate TCO very easily. One of the solutions that AWS given us is this TCO calculator. You can very easily calculate your TCO using their web interface. For example, let's say our server named as a web app have one VM and CPU cores have 8 CPU cores with 16 GB memory, and we can have a DB instance that database we have a one VM with a CPU cores 8 and 16 memory of RAM. Then we can calculate this TCO using this web interface very easily. They will provide a in detail cost benefit of this TCO calculation. Now you can see, Manoj.
Wow, I can see. I mean, it's like 95% cost saving.
Actually, for me also, this was the expression.
So this is just by kind of moving into cloud itself, right? I mean, without introducing any sort of microservices, right?
Yes.
Just by getting your workload, I mean, getting your servers and everything set up on the cloud, you get like 95% of cost saving per
Actually,
year.
the funny fact is, Manoj, your one decision can save 95% of your money.
This is quite interesting. So guys,
So now early what we had was a monolithic entire application which was hosted in dedicated servers which are located at Norway. So in our journey, what we did was like we identified the potential of cloud. So Manoj, can you tell us how we did our initial footstep to the cloud world?
yeah, Ramesh. I think as you have seen on the previous slide, basically just by migrating to cloud, we can save a lot of cost, right? So our first step in our migration process is to get whatever the things as it is, all the servers, database servers as it is, and put them on cloud. So this is how we do that, right? So as I mentioned, it's a huge cost reduction, and it has suggested in the TCO calculator. So the region we chose is Ireland region, guys, because as we have previously mentioned, there are some regulatory aspects that we have to cater for, right? For example, those customers' data has to be in those Scandinavian regions, right? So we chose Ireland. So this is our first architecture. You can see it's a very simple one. In our previous cost calculation, AWS cost calculator has suggested us one of the EC2 instance. You know, EC2s are basic some virtual machines on cloud. They have suggested a particular EC2 instance with this much of memory, this much of CPU. So what we just did is we simply just took that server and put our monolithic architecture, I mean with our the server and the database, everything in this virtual machine. So this is our first migration. I mean, this is not complex at all. We just took our servers and put it on EC2. And what we have done additionally here, guys, we have set up a route. So this is the domain of our application. It's www.myapp.com. And when someone visits this application, we have set the DNS, domain naming service, through the Route 53 service of AWS, and it will simply resolve in our server. So anyone who uses this web application can simply get served from our EC2 instance. How easy is that, Rumesh?
That's really cool. So Manoj, now we have moved our entire application to cloud, right? So we have all the production applications here and there and hosted in AWS. But this still is a monolithic application, right? So if we want to introduce a microservices architecture, but we can't do it overnight, right? So it wouldn't be practical. So can you give us any directions whether to go microservices, any aspects? So can you provide some insights how to do, and if we are to move this application to microservices architecture, what other things would you do?
Yes, the first thing, Rumesh, I mean, now that we have set up our monolithic application in EC2, Amazon EC2, then we have this the requirement. I mean, how can we kind of cater for new features? For example, by the time we migrate this whole system into AWS, we have been developing a lot of features, right? So we got a lot of new features as well to be developed, right? Previously, we have been developing on our monolith architecture, but now we can't just fall into the same pit that we fell earlier, right? So what we have to do, we have to differentiate. When it comes to new features, we have to find a pattern that it will be easier to migrate into a microservice architectural pattern. So this is what we have done. In order to kind of create a serverless microservice architecture, we need to have these three components. As you can see on the slide, we need to have a CloudFront distribution, API gateway, Lambda. Now I will get back to this, what this really means. CloudFront distribution is basically our proxy service. Why do we need a proxy service? Let me go to my next slide. You can see this is a slightly different slide from our previous architecture. You can see this is our monolith here, right here. And we have set up this CloudFront in front of that, right, as the word implies. So anything, if a user simply just browse www.myapp.com, he will be simply directed to this monolith application. Now the different thing that we have done is when it comes to new features. What we have done is we have added a new API. This is using AWS Amazon API Gateway. Now this is just another API that is managed by AWS. It is serverless. We don't have to manage any servers. Of course, there are servers behind the scene, but we don't have to manage it at all. So this is managed by AWS, and CloudFront is managed by AWS. Why I meant CloudFront is a proxy service is he can identify if a request has /API at the back, right? For example, www.myapp.com/API, he knows where to direct it, right? So it will direct to the new API. If it is not if it is a regular request, it will direct to our old API or our old monolith. It works either way. So new servers, new features, it will go to an API gateway, and from there we have this Lambda function. Now this is, guys, in the serverless world, it's a little bit different when we compare with the servers. In serverless world, guys, when we kind of implement a when we need to execute a function, we execute some code, we can just simply execute it by asking this Lambda function, okay, there's this new code, you have to execute it as soon as you get a request from this API. What we do is we create simple Lambda function and it will trigger that code as soon as it received a request. So this is quite simple. We don't have to manage our API. We don't have to manage the function or our code. Everything is managed by the AWS. That's why it's serverless. So this is how we kind of cater for new features, Rumesh.
So what you say is, Manoj, we have our monolithic application without any modification. It is just there as it is. Whenever we want to plug some new feature, what we do is we write a Lambda function and we attach it to Amazon API gateway, and Amazon CloudFront is by default it knows how to identify the request, right?
That's correct. So we don't have any configs, guys. So it can use all features from our monolith, new features from our API gateway.
Right. So that's a good migration strategy, because we don't have to do overnight modifications to the entire application, right?
Correct. This is much of a parallel migration, Rumesh.
Right.
So we do this migration in parallel. So what we do is we don't kind of limit only this new function on AWS Lambda. We will simply and slowly migrate most of the functionalities from our monolith to Lambda functions. Likewise, sometimes back we can probably go native cloud.
Right, that's really a good strategy, considering that the operational cost, because if we try to modify entire code base within a night or go entirely microservices within a night, that will have a huge cost on the customers, right?
That's correct.
This is a good way of doing things. But Manoj, now I see we have everything like the entire monolith application in the EC2. We have all the new features coming in, going to the plug and play of the AWS API gateway. But can't we do something for our static contents, maybe our videos and all the images? Do we have to store everything in our EC2 instances? Because these things cost storage a lot, right?
That's correct, Rumesh. Actually, in AWS world, there's this de facto for those static assets, guys, Rumesh. Basically, if you have images, videos, if you just go to any AWS consultant and ask where to store this, the main suggestions or the main feedback that they will give you is go and store it in S3. So let's talk about S3.
So Manoj, okay, we imagine we go to S3, but do they guarantee that our content will be online always? So what's the difference between storing our images inside of EC2 or having our all static contents in S3?
Durability, Rumesh. It's durability and availability, right? In S3, they will kind of duplicate one of your, let's say that you store one of your images of your girlfriend on S3, right? It will make sure that it will create a lot of copies of that image and make it highly available and highly durable. You know, the durability of S3, it's 11.9. That means 99.99999 until you get the 11.9. So that's highly durable and it's highly available. And tell you what, it's not just for storing these images and videos, Ramesh. You can actually host an entire static website on S3. By static, I don't mean just HTML code, right? It can include JavaScript, it can include HTML, CSS, whatnot, right? You can just host an entire static web application on S3, and it will guarantee all that availability and durability application. You don't have to worry about any loads, right? I mean, you don't have to worry about how much requests that you get overnight, right? Let's say it's a Christmas night and you get a lot of requests. You don't have to worry about that. S3 will take care of that.
So Manoj, what you are saying is, if I have maybe a React application which talks to another backend, all I could do is put my entire web application into S3 and it will handle all the replications and the scaling, everything.
That's correct.
Wow.
That's the power of S3, Rumesh.
Oh, that's really nice. So Manoj, do we have so imagine I have these all files, but I might not use it very often. So imagine I will be using the most recent uploaded files. Do they have like a, because if I don't want to access these files, like I don't feel like I should pay for them. Do they have any strategies, Audi?
Of course, they have these three ways of strategy, storing strategies, Ramesh. The first one is normal S3 standard, right? I mean, you can store a file on S3, 11.9 durability, 99.99 availability, that guaranteed. Now, the scenario that you mentioned, if there are some infrequently accessed files, right? They have this separate storage class called S3 infrequently access. So that costs whole lot low. Now let me go to this particular site. You can see, right, in standard storage, hope you can see the slide, the first 50 terabytes of the file or the storage will cost you like 0.0223 per gigabyte dollars, right? And if you are in the infrequently accessed storage, it will cost only 0.01 per GB. You see how much different? I mean, there's a little bit of different, right?
It's like one
Half of the price. That's half of the price. And tell you what, now let's suppose you want to do backup of your files, right? Suppose you are a bank and you want to keep backups and logs. What you can do is you can set up a Glacier. This is an archive that S3 provides to you. It costs so low. See, this is only $0.004 per gigabyte. Now, interesting thing in S3, guys, you can kind of set up a rule. In the first 30 days, you keep my file in standard storage, and after 30 days, you move it to the infrequent access storage, and after 3 months, you move it into the Glacier, and just keep it there. If you want, you can delete it permanently. So there's this nice strategies defined in S3 that you can utilize when it comes to cost saving.
Right, great. So now I understand all the benefits of S3 and how we can use it. But can you simply show me how we can plug this to our architecture?
Yes, it is about my next slide, Ramesh. You can see we have talked about how we have parallelly run our monolith and our serverless application. Now serverless is for new features and monolith is for all features. Now there is this S3 that we can plug in to our CloudFront as another URL. You can see how easy that we can plug this S3. For example, previously we had all these images, videos on our instances itself, on the EC2 itself. That will cost you a little bit more because it's the compute capacity, storage that you have to pay for that.
And even for the streaming, we have network cost as well.
That's
right?
true. So what we can do instead is, whenever user upload an image, we can just track that URL from CloudFront. You can filter it. If the URL is some form of slash images slash star, just put it into a S3 bucket, not inside our EC2. So this is how easily we can just plug this S3. Now I have another thing to share with you guys. In a CloudFront, it's not just a proxy, guys. In CloudFront, we can cache the images. For example, we might not want to cache our API gateway, right? Depending upon your scenario. In our case, we don't need to cache it in our API gateway. So we set the cache 0 when it comes to API gateway. But when it comes to S3 bucket, images quite less often they get changed. So we cache it right here. So whenever user try to access an image, the first time it will go direct to the S3 bucket and get it from the S3 bucket, and on the way it will cache it on the CloudFront itself. So the next time a user try to request it, it will just deliver it from the CloudFront.
That's really amazing. I was wondering, if I have to implement all of these things, how much of money would I cost? So I will have to buy certain servers from different regions, but that will cost me a lot. Manoj, we talked about many things, we initially had a plain old virtual machine. So currently containerization takes place a lot, and a lot of people are talking about containerization. can we move our application to maybe a Docker environment or any other container service? Could you give a brief introduction? Or?
Yes, of course, Ramesh. When it comes to containers, Ramesh, I mean, they are like servers, right? I mean, if you want to run a particular service for the longest time, you can simply spin up a container at a very short period of time and have it kind of cater for your request. So another question that comes to my mind, or maybe to viewers as well, is can't we use Lambda, so the ones that we have talked about, to run our application server? Now I think the reason you asked this question is, Rumesh, you have mentioned that we have been using a Ruby on Rails application,
Yes,
right?
exactly.
And so we have this application server, and it is bound with our front end, right? So I mean, can't we just host this application server in a Lambda itself? Can't we do that?
Yeah, that was exactly my question.
Yes. So now get this. In Lambda, Ramesh, it is not a persistent server. What the idea in Lambda is, it will just cater for your requirement as soon as a request approach to the Lambda. So what will happen is, as soon as a request come through the API gateway to a particular Lambda, what it does is it will quickly spin up a small container and serve that particular request, and it will just turn down that container. It does not kind of keep it live for a longer time. So there are, I mean, for a good half of our program, we can kind of use Lambda. For example, if I want to get something run, get something processed, I can simply write a API gateway endpoint and call that Lambda and get that thing processed and get the results. But if I want to have some long running process, we simply can't use Lambda. So that is the place we might need to kind of invest on a long running container. So that's how the ECS fits into our model.
So what you basically wanted to tell is AWS Lambda is not a silver bullet at all, but there are many applications which we can use Lambda, right?
That's correct.
Okay, so Manoj, can you quickly give me an introduction about what is ECS and how can you use it?
You have mentioned about Docker, right?
Yeah.
So there are different containers. I mean, there are different ways that we can run containers. Docker is one of the ways. Kubernetes, there are different ways that you can run containers. So, for example, you can run a whole web application or an application server in a container, right? But it's not only it is not the only component that you have in your system, right? There are other components, there are other services, there are other servers that your service needs to communicate with, right? So in that type of scenario, you can have other services also inside containers. When you have like these multiple containers, the requirement arises, you need to kind of control and manage these containers. So what do I mean by managing containers? Now I told you these containers can spin up quite fast, and so when it comes to there are multiple containers, you have to make sure that they are highly available. In order to do that, you have to make sure at least couple of those services are up and running. In order to do that, and also you must not forget there are situations that containers could go offline. So if one of your containers go offline and your entire production system goes down, so you will be in a big trouble. So in that type of a scenario, you have to have a container management system to identify these scenarios and kind of remedy those things. So that's why we need a container management system, and in the AWS world, the container management system is ECS.
So what does ECS mean?
Elastic Container Service.
Right. Okay. So Manoj, why don't we give our users how we can move our application to ECS?
Yes. First of all, it's quite simple. Now, the reason why we use in ECS at all is to kind of maximize the resource utilization. I will get back to this a little later. So let's look at our the architecture. Now you can see it's getting little more complex right now. So let's see. So this is our S3 bucket, you know that, and this is our API. We have talked about this. And now, instead of our monolith, this is the time that we try to break our monolith into microservices. So this is the approach we followed at first. What we have done is, we have a load balancer here. Why do we need a load balancer? Because we have multiple services, as I previously mentioned, that is managed by the ECS, Container Management System. So when we have multiple services, we should have some way to direct requests to those services, maybe equally or maybe depending upon a rule that you suggest. So that is why we have set up a load balancer here. And in ECS, now we have this EC2 instance. Now ECS also kind of powered by EC2 instance, Rumesh. So it's basically, you have this, the bottom layer comprised of EC2 instances, and on top of EC2 instances we spin up containers. Now why I said that container management system is efficient, ECS is kind of maximize the resource utilization is, if you just use an EC2 instance and spin up a server, you can't spin up more servers in that EC2 instance. But what with containers, what it does is, you can spin up many more containers on a same EC2 instance or on a same server. So in this example, in this architecture, you can see we have this app service. It's a Docker container that's running on one of the instances, and there's another instance here. You can see there's two words called availability zone 1, availability zone 2, and there's another service. Now why I put these yellow color dotted lines, guys? Because if this was kind of if I get a consultation from an AWS guru, he would say there's no point of you having this load balancer unless your services are in two different availability zones. He has a point. Why? Availability zones are, guys, two separate geographical areas. It will make sure that if one of the availability zone, for example, let's say in Sri Lanka, in Jaffna we have one availability zone, in Colombo we have another availability zone, right? There could be a flood in Colombo, and because of that our data centers got lost. But still again, we have a separate geographical area in Jaffna where our servers still are running. So even though there's a big catastrophe happen in one availability zone, our system will still be functioning. So that's why we have these two availability zones to make sure the high availability information.
Okay, so Manoj, now we saw that we have introduced a lot of complexity to our application. So by reducing cost, we are sacrificing the simplicity of the application development cycle, right?
Yeah, in a way, I would say. Yes.
Okay, so Manoj, in our application we had different other services as well. So one of them being is the WebSync microservice and the WebStamp microservice.
Yeah.
So can you tell me how to plug in these other microservices to our architecture?
Ramesh, before getting to that, I would like to comment on your previous question because I just got something to my head. Basically, in today's world, you said now the architectures are getting complex and complex and complex, right? Now, it's kind of the inherent thing in today's enterprise application, Ramesh. You know, old days, most of the complexities of our applications lies in our code. Now, those complexities have been kind of handed over to the architecture. So, when we are designing an architecture, these architectures are getting complex and complex, and that will make sure high availability, high durability, security, all that will be kind of confirmed by this complex architecture. So this is kind of inherent nature when it comes to enterprise application nowadays, Ramesh.
But then again, it will obviously remove the cost factor and it will give us a low TCO, right?
That's very true. We will get to that.
So coming back to our the other additional microservices, WebSync
Yes.
and WebSnap.
So basically, there were two other microservices we had to place in our project. So you saw that we have our application server microservices running in one of our containers. So we had these WebSync microservices. Now this is nothing but kind of syncing user interactions among multiple users. Of course, one of the things that you might be remembering right now would be the WebSockets, right? It's kind of a real-time communication happening across multiple users. So we have to kind of cater for this. If someone do a change, another one should be able to see and collaborate together. So this microservices handles that. Now Ramesh, unfortunately, we couldn't have kind of plugged these microservices into our ECS. Now the reason behind is this. In our microservices, let me go back to my previous architecture. I told you we have been using load balancer by then, right? So the old load balancer that AWS has provided did not support this microservice WebSocket protocol, right? This operates on layer 4. I hope you guys remember your OSI models, layer 4. So so HTTP and HTTPS kind of runs on layer 7. Somehow, so this didn't quite suit well in our WebSocket protocol implementation. So what we had to do additionally, Ramesh, we had to kind of spin up a new server, EC2 instance on our AWS platform and just put that service into that. Now the things is different when it comes to WebSnap microservices. This is basically to take a snapshot of a particular website and just render it as an image. Right? Of course, this doesn't use WebSockets, so we can easily use another container spin up in our EC2 container management system. So this is now. Let me go to the architecture. You can see we have the app service running here, as you have previously seen, and we have our snap service running here. So now we have two microservices in our ECS, Elastic Container System Management System.
Isn't it a little bit costly, Manoj?
It's not costly, Ramesh, because you see, both of these microservices use the same EC2 instance. For example, let's say take this availability zone. It has this one of the EC2 instance, and it has these two microservices that are running on the same instance, right? So I can spin up more of these containers in here. If I had another service, I can simply spin up another service. Now the challenging part is this, guys. The ELB that we have used, load balancer that we have used, has a limitation. If you have spin up a Docker container, you have to kind of map port between your container and your host operating system, because for the outside world, for example, for the cloud load balancer, it can see only this instance, the main instance. It cannot see this containers that is running inside that. In order to communicate to that, we have to kind of export a port from our instance to the my container. Now, in problem, what we had in the old load balancer, I'm talking about this old load balancer. I will get to the new one after this, right? It cannot kind of cater for multiple ports for a single EC2 instance. Obviously, if I want to access this app service, there should be a one port. If I want to access to this snapshot service, there should be another port. This didn't really work with the old load balancer. So as a remedy, what we had to use is a reverse proxy using Nginx. So that's why we had to kind of spin up a reverse proxy container inside our EC2 instance, such a way that it will kind of delegate the right traffic to the right container using virtual names, basically.
So all the service discovery is also being taken care of Nginx, right?
Correct. Service discovery is taken care by the Nginx.
Right. So Manoj, after all these modifications, we had another different business requirement called we had to basically white label our product.
That's true.
So if we are white labeling our product, can we use the same EC2 fleet, ECS fleet we are using?
Ramesh, when you are kind of working on a project, there are lots of requirements coming up to you, right?
Yeah.
One of these requirements is you have to kind of sync between the users so that as a solution we had to spin up a different EC2 instance.
Yes.
So that kind of boosted up our cost,
Yeah.
right? So now you mentioned another point. There was a requirement for a white label product.
Yeah, which means basically I have to replicate entire architecture, right?
That's true. So you see, just imagine, right? You have to replicate your load balancers. You have to replicate your ECS. You have to have a different cluster. And don't forget, we have another EC2 instance running for that web app sync service as well. So all these things kind of boosted our cost in our architecture. So we were a little bit worried actually. We were just thinking a little bit back and forth about our decisions.
So we talked about the limitations of the ELB. So do they have any things which can take things forward with a modified service?
That's true. Actually, we have been doing this architecture back in 2015, right? In the mid of 2016, they have come up with a new load balancer. That is called ALB, or in short for Application Load Balancer. Now, this application load balancer runs on layer 7, right? And it supports layer 7 WebSockets, guys. So this was quite I think it's a boon for us. I mean, it's quite fortunate we were, as they have introduced this new service. Now this image, it shows how we had to kind of have different ELBs when we were using our old load balancer, right? You can see, I mean, we had to replicate all these clusters again and again, cost raised up, right? Now with the new introduction of ALB, I told you it's layer 7 load balancer supported content-based routing. Now this is the most important thing, Umesh. It supports content-based routing. In previous load balancer, it supports DNS routing. I mean, you cannot kind of look at the payload of a request, because that is not a responsibility of layer 4. If you want to have a look at the payload of a request, you have to be on the layer 7. Now, since this ALB is on layer 7, it could have access to the request body, and it can see the headers, it can see the host. So with this information, it can determine where to send this request to, right?
So I'm getting a hint that if I could incorporate some sort of a parameter which could differentiate my different white label products, I should be able to get like route different applications to the different PCS locations, right?
That's true. So there's a special name for that, Ramesh. It's called rules.
Wow.
It's called rule-based routing. So let's have a look at it, right? You can see now we don't have these 3 load balancers. Instead of that, we have one load balancer. It's our application load balancer, right? I told you about rules. Now these rules are implemented in something called listeners. You can see, I told you in ALB, since it is running on layer 7, it can have access to the the hostname and about the paths that it is accessing. So in listener, we can set up the hostname and the path, and you can mix and match these two and make sure, for example, if I have the snap service somewhere here, and if I get a request like this, I have 3 applications, let's say www.myapplication1.com, myapp2.com, myapp3.com, and if I get a request from myapp1.com/snap, our application load balancer is smart enough to identify the host and the path, and he's smart enough to kind of route that request into the corresponding microservice. So it's a huge benefit, Ramesh. You know what? Previously, if I go to my old load balancer architecture, you can see, I mean, there are 3 load balancers, and of course you have to pay for these load balancers, so your costs get high, right, Chama? And now, apart from that, you have to have different instances in order to have kind of highly available in 2 different availability zones. So at least you need to have 2 instances on 2 availability zones, right? So likewise, how many, if you have like 3 white label applications, you have to have 1, 2, 3, 4, 5, 6 instances. Now in this manner, I mean, there's a huge cost benefits when we kind of switch back to the ALB. We can just determine, okay, of course, I'll tell you, okay, I will say, okay, I will use only 3 instances, right, instead of 6 instances. What I will do is, I will mix and match those containers in across these 3 instances. I don't have to worry because since my load balancer is smart, he knows how to kind of route traffic to the corresponding and correct container. So you see, there's a beautiful pattern emerging from this ALB and ECS, Ramesh.
That's a really great way of having white label products with low cost. So, Manoj, talking about still we are in EC2 instances, and currently, as I remember, they are providing different type of virtual machine. Like we could pay in different manners, right?
It's true.
As far as I can remember, we could buy virtual machines as per our requirements. Say if we want to get it only for 5 minutes, we can take it. I heard that they are offering a service which we could bid our money and kind of an auction, right? Can't we use those machines to reduce the cost?
Yes. So far, Ramesh, what we have used as our instances are called on-demand instances. Now, those are basically provided to you by your demand, right? For example, you can say, okay, if my load is up, like CPU load is more than 75%, I need another instance. You can set up that rule, and what AWS will do is, as soon as your load gets higher, it will just provide you another instance. Now, this is really good in case of a spike traffic, Ramesh. For example, let's say Black Friday, something like that, right? On that, we can beforehand say, okay, if my CPU utilization goes more than 75%, just bring in more servers, right? So it's on demand, right? Now the problem here is, guys, this is kind of cost based on per second, right? Every hour, per hour billing also there, per second billing also here in on demand instances. So it's little bit, I would say, costly when you compare it with spot instances. The spot instances, like you mentioned, we can place a bid on a particular server. Okay, this is how much I'm gonna bid for a new server. If my bid is good, just get me a new instance, right? Now, this is another kind of a benefit that we get from the economy of scale of AWS, Ramesh. Because in their data centers, they have a lot of compute capacity, lot of servers, lot of hardware, and lot of memory, all that, right? They don't want to kind of make it idle all the time. What they have done is they have created a marketplace where the people can place bids, and if they are within that bid, they can of course just get some more instances, get some idle compute power, memory to their systems. That's if you look at this slide, you can get a good comparison over the cost. Now, the thing is, they are way cheap, right? Just take a look at this example.
Yes, I was wondering why these are in average they are saving over 70%, right?
That's true. For example, C1 medium with 2 CPUs and 1.7 memory, if you compare with on demand and spot instance, you get like 80% cost saving. How awesome is that? So we've been thinking, Ramesh, I mean, when it comes to containers, only requirement what they have is to have some sort of a resource, compute resource and memory to run them, right? To spin up a new container. Is there a possible way that we can make use of these spot instances and get a big cost advantage and make sure that our system works like that? So that's the thing that we had to look at afterwards. Actually, it turns out pretty well. So what we had was we had kind of replaced our on-demand instances with a fleet of spot instances, Ramesh. Now you might be wondering, what happens if my bid is low? So
Yes, so if my bid is low, that means that I don't have access to those instances so far, right?
so that's what happens when your bid is overrun by someone else. AWS will terminate that instance. That's a risk, right? I mean, we can't run our production workload on that sort of uncertainty. Now, thankfully, before terminating the instance, AWS give us a 2 minutes, a warning before 2 minutes. Right? We have to utilize that 2 minutes and make sure to at either raise our bid or else request another fleet of spot instances. Now, we have to kind of set up our systems in a way that it handles this risk, Ramesh. If we could handle this risk, we get a lot of cost benefits. But for the safe side, Ramesh, we have another reserved instance in our fleet as well.
So Manoj, can you tell me the difference between a reserved instance and on-demand instance?
Yeah, there are 3 different types of instances in AWS, Ramesh. One is on-demand instance. I explained to you about that, right? That's really good for spiky traffic conditions, right? And the spot instances where you can bid for idle capacity and get service like that. Third one is the reserved instances. This is basically, you pay for your compute requirement and memory requirement upfront, right? You say, okay, I'll be using this server in for about 3 more years, so I will pay it upfront, and by doing so, you get a big benefit. You get a big discount on the service. Actually, the cost benefits that you can achieve is up to 60-70%.
Okay, so that means that we guaranteed AWS that we need this particular instance for a guaranteed period, so that they will give us a discount, right?
That's true. So we have this reserved instance plugged into our instance list, Ramesh. So we have that confidence. Of course, we have kind of addressed in a way if our spot instance get terminated, get a beforehand notice, and we will spin up a new instance or raise our bid limit. But for the safe side, we have a reserved instance as well, so we don't have to worry about that. Our cost is so cheap.
Okay, so so far we discussed many different approaches. So to put everything into summary, so Chamal discussed about the total cost ownership of a company and what are the how it could affect the company, and how you can migrate your monolithic application into a microservice based application, which could save you a lot of money. So basically, to recap all the steps what we discussed so far was, initially by just taking your monolith application from on-premise to just by moving into cloud, we save a lot of money. And then the second thing Manoj discussed was
parallel migration to serverless Lambda, which is of course a requirement when you have an existing payload on your on-premise and migrating to the new one. On AWS. And then we talked about different S3 classes where you can store your static assets depending upon their frequent and infrequent access, where you can get a lot of cost benefits if you identify your requirement correctly.
And then we talked about containerizing your application and moving into a managed containerized environment. And if you have different like white label products or maybe even different applications of it, how you could leverage the power of application load balancer instead of elastic load balancer.
And of course the cost benefits that you get if you use the ALB instead of ELB.
And then finally we talked about rather instance using on-demand instances, how you can leverage the power and the cost benefits of spot instances and the reserved instances.
Yes, I think that's the whole thing that we need to discuss within this webinar, Ramesh.
Yes.
And Chama.
Yes, of course. Actually, carefully planned architecture will lead to a carefully planned cost plan.
That's a very good statement. Actually, when we decide beforehand, we have to think a lot. We just can't spin up on-demand instance and use it Just think about the context, think about the application, and they apply what's best for you and what is best for your organization goals, basically.
So with that, we would like to come to an end to this webinar. So we'd like to thank all our crew behind us, because other than three of us, we had several other people who helped us a lot with the infrastructure setup, which could take things live. So with that, we would like to say goodbye, and we'll be meeting you with another webinar series. See you guys.
Have a good one, guys. Bye.